Dear students, good evening. Today we are going to discuss the hematological malignancies, that is the leukemias. The learning objectives for this particular sessions are the clinical manifestations and classification of leukemias, demonstrate the knowledge of clinical features of leukemias, acquire the knowledge of clinical and laboratory approaches, interpret the laboratory data for diagnosis of leukemias, and also acquire the knowledge of principles of therapeutics of leukemia and recognize the treatment and complications. As you know, hematological malignancies, by definitions, these are the leukemias or lymphomas and multiple myeloma. They are the interrelated spectrum of malignancies of the myeloid and the lymphoid series. These group of hematological disorders are characterized by clonal expansion of hematopoietic cells which has undergone genetic mutations. If you see the hematological malignancies per se, they are relatively rare diseases compared to the other malignancies, that is around 10 per 100,000 per year. They are being classified as the acute leukemias, which has a short natural history, and other one is the chronic leukemia, which has a long natural history. The other classification is the myeloid and the lymphoid origin. More than half of the leukemias present acutely, that is acute lymphoid leukemia and acute myeloid leukemia. Remainder being chronic types, that is chronic lymphoid leukemias and chronic myeloid leukemias. Acute lymphocytic leukemias, they are more commonly seen in the childhood. Chronic lymphocytic leukemias is a disease of the elderly. Leukemias can be diagnosed by examination of the stain slides or the bone marrow examinations. Also, there are newer techniques like immune phenotyping, cytogenetics, molecular genetics, which can lead to essential classification and also the prognosis of the various types of leukemias. If you see this picture, you find that on the left side of the picture there are some normal cells and there is a mutation taking place, and then ultimately you find that there are the malignant cells. Going to the etiology of these diseases, per se there is no known etiology, but there are various factors which have been attributed to leukemias: radiation, chemicals and drugs, genetic abnormalities and viruses. Radiation that can induce genetic damage to the homeopathic precursors, and acute lymphocytic, acute myelocytic and chronic myeloid leukemia have been seen with increased incidence in survivors of Hiroshima and Nagasaki and patients treated with ionizing radiations. Drugs which have been attributed to onset of leukemias, the benzene industry may lead to marrow changes. Acute myeloid leukemia occurs after treatment with alkylating agents, that is melphalan. The genetic incidence of leukemias is increased in identical twins and in syndromes of somatic cell chromosome aneuploidy, that is Down syndrome or Klinefelter syndrome. Viruses which are associated with leukemias are human T cell lymphotropic viruses, that is HTLV1, which is found particularly in Japan and Caribbean islands. If you see the overall etiologies of the malignancies, this is a combination of genetic background, environmental influence that determines the risk of developing hematological malignancies. There are environmental factors like we have seen chemicals, drugs, radiation, infections, etc. The genetic abnormalities in leukemias, the Philadelphia chromosome was the first chromosomal abnormality associated with chronic myeloid leukemia. 97% of the cases of chronic myeloid leukemia are associated with Philadelphia chromosome. These genetic alterations change the normal cell regulation and interfere with the control of normal proliferation. blocking the differentiation, maintaining an unlimited capacity for self-renewal, and lastly promoting resistance to the death signals, that is decreased apoptosis. The Philadelphia chromosome is also found in acute lymphocytic leukemia. The incidence in the later illness increases with age. The Philadelphia chromosome is seen with a translocation of the chromosome 22 and the chromosome 9, and as it has been shown in this diagram, the long arm of the chromosome 22 has been reciprocal translocation with chromosome 9. Go further to the genetic abnormalities in leukemias. Almost all patients with acute promyelocytic leukemias, a subtype of acute myelogenous leukemias, have the reciprocal translocation, that is between chromosome 15 and 17. Occurs at the Q band, 25 band of chromosome 15 and Q22 band of chromosome 17. The breakpoint on the chromosome 17 occurs in the gene encoding the retinic acid receptor, fusing it with the part of the promyelocytic leukemic genes. There are other surface markers which have been identified, and these can also classify the leukemias into acute leukemias. Immature myeloid cells have cell surface markers, that is CD13, CD14, CD33, CD34, which can be identified using the monoclonal antibodies. The majority of the patients with acute lymphocytic leukemia, that is 60%, for example, show the common acute lymphocytic antigen, that is also called CALLA CD10. If you see this picture, then you can see that there are oncogenes, also anti-oncogenes, which are also called tumor suppressor genes. And these, on first picture you see the normal cells, and in the second picture you see the malignant cells. These oncogenes, together with chemicals, radiations, drugs, viruses, translocation, ultimately lead to the malignancies. And the same picture, if you see, there are certain chromosomal abnormalities, like P53 has been recognized as the guardian of this genome, and this mutation in this particular genome to the 50%, tune of 50%, has been identified for formation of malignancies. There are certain inherited factors. The patients, particularly who have genetic abnormalities like Down syndrome, trisomy 21, Wiskott-Aldrich syndrome, Fanconi's anemia, ataxia telangiectasias, Bloom syndrome, all these are more associated with these hematological malignancies. The environmental factors, which we have already discussed, as I have told you, that chemicals, drugs, radiations, also infections which have been identified. Let us go a little bit on the WHO classification. There is another classification, FAB classification, which I will go later. The WHO classification states acute myeloid leukemia and then chronic myeloid leukemias, and they are associated with different types of genetic abnormalities. You can go through them, and also the acute myeloblastic leukemias or acute lymphoblastic leukemias. If you see the normal hematopoietic cells, they are initially divided into lymphoid stem cell series and myeloid stem cell series, which form lymphocytes, and myeloid stem cell forms the other blood cells. Then if you see the lymphoid stem cell series results into lymphocytes, myeloid stem cell series comes out to be RBC, other WBCs and platelets. And whenever there is a leukemias, there is a changes in the lymphoid stem cell series leading to the lymphoid series, and then there are myeloid stem cell series which lead to the myeloid leukemias. And this is what has been shown in this picture, and there are myeloblast and lymphoblast. And these are the four major types of leukemias: acute lymphocyte and acute myeloid leukemias, chronic lymphocytic leukemias, and chronic myeloid leukemias. The same thing which we are seeing now, there are pre T lymphocytes, then precursor cells, which are again leading to acute lymphoid series and chronic lymphoid series. Then there are pro-normoblasts, which lead to acute myeloid series and chronic myeloid series. If you see this picture, which shows the blast cells into the peripheral blood film, and the picture down below shows the bone marrow, which is showing a increase in the cellularity. These are the basic changes which you see during the examination into the peripheral smears and into the bone marrow for diagnosis of leukemias.